Hello, my name is Maria Colgan, and joining me today is my colleague Ashish Ray. Together we'll describe the 5 key ingredients you need to build and deploy mission-critical databases. We'll share examples of how customers are leveraging this strategy in production today and explain how Oracle's cloud databases make it even simpler. Whether you're building a new mission-critical application or you have new analytic needs, you're going to need a database to safely store and access your data. That database needs to have a high availability architecture to support 24/7 operations. It also must protect your data from attack while ensuring that you meet any regulatory requirements. So where do you begin building such a system? Well, as I mentioned earlier, you'll need 5 key ingredients to build a mission-critical database regardless of what type of workload you plan to run. First, you'll need fault-tolerant infrastructure to make sure you can withstand any type of hardware failure. You also want to ensure that that infrastructure can deliver the performance necessary for your peak workload. Next, you'll need a high availability architecture to protect the system from any local failures. You also want to ensure that that high availability architecture will allow the system to seamlessly scale up when more resources are required. You also need to protect the database against a complete site failure by creating a disaster recovery strategy. After you've protected the database from any type of failure, you need to secure it. You want to protect your most important asset, your data, from both external attack as well as any malicious internal users. Finally, once the system goes live, the app and the database will need to be updated to pick up the latest fixes and new features without requiring any downtime. I know that sounds like a lot, but don't panic, because we'll show you how Oracle's technologies can help you every step of the way. Let's start with the first ingredient, fault-tolerant infrastructure. You can use Exadata to quickly and easily protect your databases from any hardware failure, as it provides built-in redundancy at every level. Exadata infrastructure is comprised of 3 components: database servers, a storage grid, and the network. And all the servers come with redundant components like power supplies and fans built right in. The database servers operate in an active, highly available cluster, which I'll discuss in more detail shortly. But just know, if a database server were to fail, your database will continue to run on the remaining servers in the cluster. The database servers communicate with the storage grid over a redundant converged Ethernet internal fabric, while clients can connect to the database over a highly available bonded network. The data is stored on a redundant storage grid that automatically mirrors the data across multiple storage servers. And if some of the data were to become corrupt, Exadata simply reads from the other side of the mirror while it repairs the corrupted data. If a repair isn't possible, Exadata will automatically create a new mirror for you. Because Exadata is a combination of hardware and software that has been engineered to work together, it can instantly detect a database server, storage server, or network failure. If Exadata can't repair the hardware, hot swappable components allow easy online maintenance. Let me hand you over to Ashish now, who'll share how customers are benefiting from Exadata's fault-tolerant scale-out architecture.
Thank you, Maria. In fact, PayPal is a great example of how the world's premier digital payment processing company is banking its business on the fault tolerance, performance, and security capabilities of Exadata. PayPal has rolled out a fleet of scale-out Exadata systems to enable its payment, risks, and compliance applications, leveraging technologies such as persistent memory and hybrid columnar compression, as well as built-in database high availability capabilities such as RAC, Active Data Guard, and Golden Gate to drive enormous performance and scale. On top of that, with Exadata's built-in consolidation features and integrated automation and high availability best practices, deployments are standardized, reducing costs and complexity.
Thanks, Ashish. Let's take a closer look at how the Exadata database servers are clustered together. Oracle provides a simple yet extremely effective high availability architecture with real application clusters that are better known as RAC. With RAC, applications run across a pool of servers connected to shared storage. And this architecture provides 3 key benefits. RAC offers complete high availability. If a server in the pool fails, the database continues to run on the remaining servers. The application is unaware of the failure because the app connects to the database via a database service rather than connecting directly to a particular server. The transparency of the rack cluster also allows the database and underlying infrastructure to be patched or upgraded while the database continues to run. The server that needs patching is simply removed from the cluster while the database is running on the remaining servers. Once the patching process is complete, the server is added back to the cluster without impacting the app or the database. Rack also offers online scalability. When more processing power is required, you simply add a new server to the cluster, and again, all of this happens while the database remains open for business. There's no need to restrict the data access or rebalance the data. Let's move on and take a closer look at our third ingredient, disaster recovery. Active Data Guard makes it simple to protect a mission-critical database from data loss or downtime in the event of a complete site outage. And it does this by maintaining one or more physical replicas or standbys of the production database. And there's no restriction on where those standby databases may be physically located, provided they can communicate with the primary. Active Data Guard uses Oracle-aware replication to keep the standby database in sync while enforcing the same read consistency model as the primary database. An Active Data Guard standby can be open read-only when it's being synchronized. This allows for read-mostly workloads to be offloaded to that standby database. The standby database can also be used to reduce downtime and risk for many kinds of planned maintenance operations. Changes can be first implemented on the standby database, tested, and then when you're ready, you can simply switch over. The production database runs unaffected on the primary database while the maintenance is being performed on the standby. Downtime is limited to just the time required to switch production to that upgraded standby. Finally, with Active Data Guard, you can manually failover to the standby as I just described, or you can take advantage of automatic failover, which eliminates the time required for a human to respond to an outage. With automatic failover, a third-party observer is in constant contact with both the primary and the standby database. If it loses contact with the primary, it initiates the failover. The standby database will be opened read-write, and the primary database services are started there. Transparent application continuity breaks the client out of the TCP timeout, and the apps quickly reconnect to the new primary database and resume. Let me hand you over to Ashish now, who'll share how Oracle's cloud databases are making it incredibly simple for you to provision and run mission-critical databases that are automatically including those first three ingredients I just described.
Absolutely, Maria. You talked about Exadata, Rack, and Active Data Guard as the premier components of our mission-critical database technologies. For our mission-critical database cloud services, we have made deployments of these technologies infinitely simpler. So, for example, with the Exadata database service, which can be deployed either in Oracle Public Cloud or in a cloud at customer model, the provisioning of an Exadata system with built-in Rack and optionally Data Guard for DR is completely automated. If customers choose, they can also scale up OCPUs dynamically to accommodate peak workloads. Autonomous Database builds on this paradigm by enabling even more automation, such as provisioning Autonomous Data Guard for automatic failover, ensuring seamless DR protection, and also automatic OCPU scaling for handling workload fluctuations seamlessly. In fact, our ongoing work with Deutsche Bank is a great example where all these premier technologies and cloud services are coming together. As we announced last year, Deutsche Bank decided to adopt Exadata Cloud at Customer for all the value proposition we have identified so far, in essence, to enable end-to-end bank modernization. This touches on several of its core applications, such as trading, payments processing, risk and capital planning, and regulatory reporting. Deutsche Bank already had prior experience with the performance, availability, and scalability features of Exadata. With Exadata Cloud at Customer, all of these capabilities are now available to them with significantly enhanced automation in a cloud consumption model where infrastructure maintenance is completely Oracle's responsibility. For Deutsche Bank, this boosts productivity, reduces costs, ensures data residency, drives better data insights, and acts as a catalyst for bank modernization.
Thanks, Ashish. I want to move on now and talk about security. After all, mission-critical databases are valuable repositories of sensitive information and often include intellectual property, financial data, or personal data about your customers or your staff. Oracle makes it simple to secure mission-critical databases with our maximum security architecture. Let's take a closer look at that architecture in action. Since data is eventually going to be persisted on disk, you need to protect it from attack right there. By encrypting the data at rest, you can ensure if anyone accesses or steals the physical disks, they won't be able to read your data. If you encrypt your data, you need an encryption key, and that also must be protected and distributed securely. For this, you want to take advantage of Oracle's Key Vault. It will store the keys securely and help you manage them when you need to rotate them. By default, administrators have privileged access to all data. However, if those credentials are stolen, hackers will also have access to everything. To protect against this, you can use Database Vault. Database Vault lets you separate database administration duties from access to the data within the database. When data is accessed from outside the application, you may also want to provide additional protection for sensitive data like credit card numbers or taxpayer IDs. And you can use data redaction to hide that sensitive data on the fly as it leaves the database. At this point, we've done a lot to protect the database, but you may also want to ensure that you can detect any attempts to break in and steal your data. You can configure auditing within the database and feed the audit events to a centralized audit vault for analysis, reporting, and alert generation. You can also use Database Firewall to examine incoming connections and SQL statements for anomalies and violations of your policies. Finally, you may need to control the access to the data right at the row or the column level, and you can use label security to do that. Alternatively, you can prevent anyone, including the application users, from modifying data by taking advantage of blockchain tables. Blockchain tables are immutable tables or insert-only tables that cryptographically chain rows to prevent anyone from tampering with the data. Oracle's cloud databases and our free database security service, DataSafe, make it incredibly simple for you to keep your mission-critical databases secure. Oracle Cloud Databases automatically take care of many critical database security elements, including encrypting the data both at rest and in motion, preventing administrators from seeing the application data, and keeping the system up to date with the latest security patches. To help you with the other aspects of securing your data, you can take advantage of DataSafe. DataSafe is a unified security dashboard to help you answer critical data security questions, such as where is our most sensitive data located and who has access to it. It also provides alerts when it discovers inappropriate user activity and addresses other sensitive compliance requirements via user assessments, user activity auditing, sensitive data discovery, and data masking. DataSafe is a free service for all Oracle Cloud databases, but you can also use it to protect your existing on-premise databases too. Let's move on and talk about our fifth ingredient, continuous delivery. Oracle databases make it incredibly simple to take advantage of a CI/CD approach for deploying new features and software updates by supporting complete online schema and data evolution. With edition-based redefinition, Oracle databases support online application upgrades with uninterrupted app availability by allowing two completely different versions of the application code to be active simultaneously. When you roll out a new version of the app, all new sessions will use that new code, while existing sessions can continue to use the pre-upgrade application code until the user decides to end the session. Once all the users have cut over to the upgraded version, you can remove the old application code. And it's not just application code that developers can evolve fully online. Oracle allows all schema changes to happen online, including adding and removing columns from a table, partitioning or repartitioning a table, creating and refreshing materialized views, and anything else you might need to do to your schema. These techniques are used by our own Oracle application teams to deliver their application upgrades. Let me hand you over now to Ashish, who'll share details on another customer who's leveraging these ingredients to deliver their mission-critical database systems.
Thanks, Maria. 7-Eleven, which is North America's largest convenience store chain, is one such example of a customer leveraging Exadata database service and a suite of Oracle database technologies in Oracle Cloud Infrastructure. The technologies that we have mentioned so far in this session, Exadata, RAC, DataGuard, database and cloud security, and agile DevOps model, all of these are critical elements of our cloud data management solution that attract premier customers such as 7-Eleven to our cloud. 7-Eleven's journey to Oracle Cloud is especially noteworthy since it started with leveraging Oracle Cloud for DR, incurring minimal disruption to its existing systems. Thereafter, it gradually switched over its production applications to Oracle Cloud, spanning prod, DR, and test dev across Ashburn and Phoenix regions. This involves various business-critical applications such as ERP, merchandising, data warehousing, and product lifecycle management. Of course, this means that along with Exadata performance, they have also enjoyed significant cost savings through the decommissioning of physical data center assets related to previous on-premises systems. So, let's summarize the key database technologies essential to mission-critical solution deployment. As Maria pointed out earlier, you will need Exadata's fault-tolerant and high-performance infrastructure to protect from any failures and scale to any workloads. You will need a database-integrated high-availability and scalability architecture enabled by RAC. You complement RAC with an integrated data protection and disaster recovery solution enabled by Active DataGuard. Oracle Maximum Security Architecture ensures protection of your data from both external attacks and malicious internal users. Finally, you need the Oracle Database integrated online schema and data evolution capabilities to ensure continuous application enhancements with no downtime. And of course, all these innovative solutions are available in a completely integrated and simplified manner with our unique cloud data management solutions such as Exadata Database Service and Autonomous Database. As the various customer deployment case studies demonstrated, with our cloud database solutions, you get unparalleled performance, availability, scalability, and security, along with tremendous cost savings. Thank you for joining us today. You can learn more about these essential database technologies in the next 5 sessions in the Mission Critical track, and also by trying them out yourself with our free hands-on labs available at the URL shown in the screen.